In this video, I'll be going through the YTSS Prelim 2022, question 8. So for question 8, I'm checking whether you are good at your electromagnetism. So in the first question, part A, I'm asking you about the conventional current. So if you can visualize the circuit properly, you should have no problem answering this. For those of you who couldn't figure out why the current moved that way, please come and see me. You are supposed to use your right hand grip rule. Okay, then for part B, most of you who got it wrong is because you thought that the spring is responsible for the contraction or expansion. So down here, the spring, although it is conducting, it could make of copper, which is non-magnetic. So there are some of you who thought that, because a current flowing through a solenoid, there would be a magnetic field, and the magnetic field would induce a certain pole on the spring, and then because of that, the spring will either contract or expand the solenoid. So that is wrong concept. The spring actually plays no part in the contraction or the expansion, right? It is over there so that my contacts could be complete because I want it to be stretchable. Okay, so how do I figure out whether for part B, whether this solenoid over here would contract or expand? Basically, what I'm trying to check is that, do you notice that in part A, after you draw the conventional current, you will notice that the current flowing through each of the coil are actually moving in the same direction. And if you recall, there's a part in your content whereby if you have two straight wires, where did I draw it? Okay, when you have two straight wires, and if the two straight wires are having current flowing in the same direction, the resulting interaction between the magnetic field will give rise to an induced attractive force, right? So because of that, if you look at it here, A and B, you can see current are flowing in the same direction. So similar to this case, there will be an induced attractive force between the two wires, and so the coil will contract, right? The coil will want to move nearer to one another. Now, whenever you want to explain why a force is induced, then it is important that you recall that it is due to interaction of magnetic field. And because it is an interaction, it means that there must be more than one magnetic field, and you need to tell me that field A and field B, where are they coming from? So down here in the explanation, you need to tell me that first, you notice that there's a current flowing through A and B in the same direction, right? And when you have current flowing through A and B in the same direction, what happens is that there will be magnetic fields generated, and due to the interaction of these magnetic fields, an attractive force will be induced, and they will therefore attract each other. Okay, so the answer is here. For those of you who is watching this video through YouTube, you can always go to my OneNote, and you will see the full answer over there. Then after that, in part C, basically it is a very simple, straightforward question asking you, how do you magnetize a nail? However, I can see that many of you in your responses, you have included things like the magnetic field will align the domain, so on and so forth. What you are trying to answer is, why does it get magnetized when it is being placed in a solenoid? But that is not the question. That's not the question, right? The question is simply asking you, can you tell me the steps on how to magnetize a steel nail if you are having a solenoid? That's all. You don't need to provide any explanation. So I'm only looking at steps. So in your steps, of course, you need to tell me that you are going to place the steel nail inside the solenoid. And because the nail is made of steel, the steel is a hard magnetic material, and hence you need to tell me that you need to wait for a while. So I'm looking for this statement after a while. Then it is also important that for magnetization, you actually need to open the switch before you remove the steel nail. This is different from demagnetization. In demagnetization, you want to keep the switch on. You want to keep the switch on before you remove the material, that magnet that you are going to demagnetize. So for magnetization, you open the switch, then you take out. For demagnetization, you keep the switch closed, take out, then off the switch. Okay, so in this question, basically we are testing you on really basic content. I would say that in part B, we really need some insight into noticing that, oh, okay, in part A I can see that the current are moving in the same direction. Okay, if you still have a further question to why your answer is not accepted, do not wait, always come to me and I will give you an explanation. Yeah, okay, that's all. Remember to subscribe